Question number 16 is another complete graph analysis. So my first step is going to be to factor the function. So I want to first factor. That'll be 3x, and then this will be x plus 1, x minus 1. Okay. Part A is talking about the wholes, and that will occur if we have any factors that cancel. And we didn't have any factors that cancel. So there are no wholes or no removable discontinuities. Also, that means that when referring to this function, you can refer to this version of the function, or you can refer to this version of the function. On the previous question, we had a factor cancel out, and we always wanted to refer to the version of the function after we had canceled that out. Here, because nothing cancels out, either version you can refer to. So whatever one will make the math easier. So part B is the X-Intercepts, and I want to set the numerator equal to 0. So that's going to be 3x equal to 0, or if you divide by 3, x is equal to 0. So this is going to be 0, 0. Part C is the y-intercept. And to do that, we want to set x equal to 0. So this is going to be, and I'll use the factored version. So this is 3 times 0, 0 plus 1, 0 minus 1. So the top will be 0. This will be plus 1 times negative 1, which is negative 1. And then 0 divided by that is just 0. So this is also 0, 0. Now we kind of knew this was coming because the origin, or 0, 0, not only does it count as an x-intercept, but it also counts as a y-intercept. So because we got it in the x-intercept, eventually it was going to have to occur in the y-intercept. But it is good that the math confirmed it as well. Okay, for part D, this is the vertical asymptotes. So I want to set the denominator equal to 0. So because I've already factored it, that's good. And it's just going to be x is equal to negative 1, and x is equal to positive 1. So these are the vertical lines at 1 and negative 1. The horizontal asymptote, I want to compare the degree. And I think it's easier to compare the degree on the first form, or on this form. And you'll notice that the denominator is higher. So because my denominator is higher, that means that this is going to be the case where y is equal to 0. And we're over halfway done, so we're definitely making our way. For the domain, we need to worry about wholes and vertical asymptotes. So it can't be parts A or D, meaning the holes or the vertical asymptotes. And because we don't have any holes, just the vertical asymptotes, it's going to be, again, we have to write this in interval notation. So negative infinity to negative 1, negative 1 to 1, and then 1 to infinity. So that would be our domain. And then it wants to know, does our graph actually cross the horizontal asymptote? So is it going to cross y is equal to 0? And to do that, we need to set our function equal to the horizontal asymptote. So my function, I'm going to use this version of it, x squared minus 1 is equal to 0. So when I solve this, I like to solve it like a proportion, which means we need two fractions, and any whole number we can put 1 underneath it, even 0. So then if I solve it like a proportion, I'm cross multiplying. So 0 times x squared minus 1 is just 0. 1 times 3x is 3x. And then if we divide both sides by 3, we get x is equal to 0. So yes, this is going to cross at x is equal to 0. And we kind of knew that because if our horizontal asymptote is this is really just the axis. And we know we cross there because it's an x-intercept and it's a y-intercept. It's the origin. So we kind of knew that that was coming. Okay, so then the graph, I want to sketch the graph. And it doesn't need to be perfect. And if you want to use the calculator to get the general shape, you can. Let me do the asymptotes first, though. So we know it's at negative 1 and 1. And then as for the graph itself, I know that my intercept is here. And then for the other asymptote, it's at y is equal to 0, so it's the x-axis. You can write it a little bit above the axis so that you can kind of see it better, especially if you're not using like a colored pencil or something. But it is actually right in the axis. Okay, and then let's graph this. So parentheses 3x divided by parentheses x squared minus 1. And you can kind of see the picture. So with the asymptotes, it's approaching them. It won't reach them except for right here it crosses it. But then again, in the long run, as you go out towards infinity and out towards negative infinity, it's just going to approach it. So we always put arrows there to mean that it's going on forever and it's approaching the asymptote, but it's not going to reach it. It's a boundary in the function. So again, a lot of work on these problems, but again, this is very important for calculus.